Hi, I'm James Litley from the Okanagan Basin Water Board. This presentation is about invasive zebra and quagga mussels as a water issue for the AquaHacking Challenge BC 2020. Do you see the three invasive mussels on this picture? No? Can you see them now? Imagine it was your job to stop these mussels from infesting BC. At the Okanagan Basin Water Board, part of our mission is to protect the quality of life in the Okanagan through sustainable water management. We help to define water problems and priorities and to find solutions. That's why, as part of this mandate since 2012, OBWB has been a leading change agent to call for increased resources, government action, and public awareness of the harms caused by invasive mussels. This is the Okanagan today, full of beautiful fresh water. In many places, at certain times of year, the water in our lakes actually meets drinking water standards without filtration or treatment. Our water is also the basis for our economic drivers in the Okanagan. From agriculture to forestry, fisheries to tourism, water is the lifeblood of our region and of our province. The Okanagan is home to hot sandy beaches and nearly endless water recreation activities. Invasive zebra and quagga mussels are spreading across North America. These tiny invaders can turn a beautiful sandy beach into this. How fast are they spreading? First discovered in North America in 1986, the mussels have now infested almost every major river system in the United States and water bodies in almost every mainland US state and 3 Canadian provinces. After just 10 years. This is after just 20 years. After 30 years. And this is where they exist today. Once it was thought that they could not cross the continental divide, but people brought them on boats and other watercraft. Today, only the Maritimes, the North, and the Pacific Northwest are still free of these invaders. Now we've seen how fast they spread across land. Here we can see how fast they spread within a water body. These pipe sections show how quickly the mussels spread in Lake Mead, Nevada. The pipe on the left is new, while the next on the right is after just 2 months, 4 months, and 6 months of being in the water. Each adult female mussel can produce 1 million eggs per reproductive cycle, and in warm waters like Lake Mead, they can reproduce up to 6 times per year. This is the effect of an infestation on a lake bottom. These mussels are selective filter feeders, which means they superfilter the water, robbing nutrients 2 levels down in the food chain from fish, killing zooplankton, starving out the animals that the fish usually eat, which can reduce or eliminate native fish populations. They also increase the clarity of the water, causing the temperature to rise, which reduces the depth zone where fish can survive. They are also selective because they reject some toxins and spit them back into the water. Of course, much of this is our drinking water, putting its quality at risk. The clearer water also allows aquatic plants to spread deeper, creating other water quality problems. Together, the mussels and invasive weeds like milfoil can create ideal conditions for toxic algae blooms. Remember those pristine Okanagan lakes I showed you? This is what our water could look like once invasive mussels take hold. While there are some limiting factors for invasive mussel survival, most areas of Canada have a high or very high probability of survival for zebra mussels based on water chemistry and temperature. Quagga mussels are even less limited by temperature and water chemistry, meaning even more areas are at risk or very high risk. And when we look at the ecological impacts of each species, they are both bad. Native fish populations, which feed on zooplankton and deepwater zoobenthos, will generally decline, while fish species that feed on littoral zoobenthos generally increase. So basically, salmon, trout, and other native fish species decline, while junk fish like bass, perch, and whitefish increase. And again, for quagga mussels, the ecological impacts are even worse. Beyond the ecology, the effects of an infestation on tourism are significant. Invasive mussels attach through byssal threads to any surface, and in their larval stages, they are microscopic. This means they can travel into tiny spaces, attach, and grow. In infrastructure, the mussels move freely in the water column and attach to hard surfaces. They leach calcium out of the surface, causing corrosion. They reduce or stop the flow of water and can only be removed through industrial power 3000 psi pressure washing. As an aquahacking team, the challenge is for you to come up with a technological solution to prevent the spread of aquatic invasive mussels, to mitigate the damage they do to our infrastructure, or to control their population in infested areas. Since 2015, the province of BC has run roadside inspection stations near border crossings. These inspections rely on human or canine inspectors to identify high-risk watercraft and locate any attached invasive mussels. In 2018, the province inspected more than 40,700 watercraft. Over 1,650 high-risk watercraft were intercepted at these stations before they could enter BC waters. 81% of recorded watercraft passing these inspection stations stopped as required. That means 19% of all the watercraft which were observed passing these stations did not stop and report for an inspection as required by law. The problem is complex, with watercraft traveling across North America, potentially carrying these invaders from one water body to another. This map shows the source of all watercraft passing through the inspection stations in Montana in 2014. Each yellow dot is an inspection station, and each green dot is a watercraft. How could your team's idea help simplify this problem and make the job of prevention or detection more effective and efficient? In previously infested areas, and if prevention fails in the Pacific Northwest, the problem becomes one of mitigation and eventually control. You can see in this photo from the Canyon Lake Water Service Company in Texas how a water intake can become clogged by invasive mussels. While there are a few existing mitigation techniques for in-water infrastructure, such as special coatings and chlorination released at the point of intake, this is still a major area of research and development where your solution could help. Beyond intakes, every structure and almost every natural surface in an infested water body can become coated in mussel shells. Other, non-drinking water intakes must also be protected. In Alberta alone, there is more than 8,000 kilometers of irrigation conveyance works and more than 50 reservoirs for water storage, serving more than 625,000 hectares of agricultural land. Finally, if prevention and mitigation techniques fail, what solutions can you propose to control the effects of an infestation? Current techniques include physical, chemical, and biocontrol options, but many of these are human power intensive, expensive, or inefficient. The simplest technique shown here is using industrial power pressure washers and removing the excess shells. This can cause damage to infrastructure and equipment, must be repeated at regular intervals, and requires the removal and disposal of millions of shells. Can you come up with a better way? If your team chooses to work on a solution for invasive mussels, you could find markets in North America and globally. Why? Ontario municipalities and conservation authorities spend between 16.8 and $29.6 million every year on invasive species. Irrigated land in Alberta contributes $3.6 billion to GDP and $1.26 billion in annual government revenue. Irrigated land in Alberta contributes $3.6 billion to GDP and $1.26 billion in annual government revenue. And we conservatively estimate a possible cost of the Okanagan of $42 million per year for at least the first few years of mussel infestation. This includes direct costs and lost revenues. We have so much to protect here in the Okanagan, and more broadly for freshwater across Canada and around the globe. Will your team be the one that finds the solution? Here are a few online resources with more general invasive mussel information and about prevention, mitigation, and control methods. Thank you for considering invasive mussels for your AquaHacking water issue. Please reach out to me using this contact information, and I'll be here to help you along.